Okay, looks like we're live. Make the test as usual, just to check the microphone and such. Start playing any day now. Make the test. There we go. Okay. Didn't start where it was supposed to, but close enough. So I should actually be able to draw if I have to. Find the right window. That one. Didn't work. Try that one. That one worked. Okay. That looks like it's working. It looks like it's there. Yeah, so I don't know if I'll do that first or second or third. I have to decide. I guess I'll do it first since ferro cells will come up. So I did a little research. I got some videos to play and such. So I should be able to explain some of this stuff, what I've observed so far anyway. So far, well, anyway, the point is that, so I put a regular magnet, a flat little penny kind of magnet down on a slide with ferrofluid. And as one would expect, the ferrofluid basically made lines like it would with iron filings because of the arrangement of the magnet. It's just kind of simple. And it just kind of radiated. And as you went further away, the little lines get smaller, but their direction is always the same direction. And that's basically the finding of what the stuff is doing. It's nothing surprising at all in terms of they're behaving very much like iron filings. Now the trick is, it's very interesting how they do that, is they basically start off as a smoke, as nothing you can see. And when, at first appearance, when you look at it, they're all the same size. When they're a certain size, they're all the same size. So out here, they all look very regular and the same. And you say, oh, that's a ferro bit, but it's really not. That's already made up of little pieces of the smoke put together, so to speak. And then they can tie together in different lengths. And as they get closer, you get longer. But lots of irregular things happening because there's flows created. If you move the magnet, it creates, the fluid moves around, and very interesting that way. So the other thing I observed, as I showed you in the other video, was that the holographic image effect I sort of got off a magnet, where you get this these kind of weird little ghostly lines that seem very holographic, not in any one place. And they just kind of float around depending on where you turn your flashlight. And that's the key to it. It's really just all about where the light comes from. And it seemed the light had to have some perpendicularness. And I mean perpendicular in the sense that the magnet's here, let's say on a flat, and you're shining the light at an angle. So the magnet's on a surface, and you're shining the light at an angle, but it's still the perpendicular to that light. It's where you see the lines, but it's got two angles. So you're perpendicular to the magnet in the sense that you're shining the light at an angle, but you're also lower than the magnet. So it's coming up from like a 45-degree angle to create this illusion in your eyes. So anyway, nothing so far mysterious or weird, or, I mean, it's, I haven't explained exactly what kind of refraction is happening. So I'm going to do that with like a laser beam, shining it through it, and then get a magnified image of maybe the diffraction. But we'll see if I can get that to work. All right, so now we'll do some comments. It worked, though. At least the drawing segment worked. So we're making progress. Pretty much some progress. It's very hard getting the lighting right. See, I still got shadows, and I got way too much light now. It screws up the video, so I still haven't worked out all that. But can't have everything, as they say. Get what you get. That's what I say. It's the best I can do. Yeah, it's the best I can do today, anyway. This particular moment in history. All right, so this was, so I'll do a few comments and then we'll get to more stuff. I gotta leave room to do my blocking. So, Lucy, you got some splaining to do. This is from some Gerald Norzikoven. So I think this was on a video responding to the Miles Mathis pi equals 4, I think. Anyway, the topic is distance, not speed or velocity or speedolocity or vectors or force or friction. I'm sorry, all those are really important when you're talking about things spinning in a physical mechanism, especially a loop-de-loo and a ball bearing running through it. All those things are really important. So it's just kind of silly. I'm sorry, it's not just about distance. Speed changes. When the Earth goes around the sun, do you think it's just about distance? Because the truth is the Earth goes much faster when it's closer to the sun and much slower when it's far away. It's just one of the facts. It changes its speed relative to the sun. Yeah. Which is relative to absolute distance in this case. And it's just a fact. That's what turning requires there to be changes. So anyway, yeah, meaningless mush. You're not proving. You're just making statements. And people who just make statements without even a reference to a link, some sort of authority, some sort of evidence, just these declarations. I know what's important. Believe me, because I posted a comment. No, I'm not going to do that. So I'll just delete it. That's what I'll do. I'll just delete it for this. Do better, please. There. I hadn't done that before. A please came out of me. Amazing. So then Michael Falwell made a joke about the predictive power of quantum mechanics. Yes, it's a big joke. I've been reading about their entanglement experiments. And so if you go on the Wikipedia page for entanglement, it's just we've proven it with all these, proof. They don't really detail any of the experiments, don't even list them on the entanglement page. You have to go to the, whatever his name is. I can't remember. Spent forever there today, and I can't remember his name. Short name. But anyway, you have to go there to find the stupid experiments that whatever the guy's name is thingy. But all the experiments, yeah, they have the new ones, and they're so confident they're correct, and they basically have to do with entanglement between electrons and photons. So now photons and electrons are having relations, yeah, and leaving essence with each other. That's kind of perverse. I mean, come on, it's just too silly. I mean, to claim they have proven anything, it's just with these convoluted experiments. Yes, we created two entangled photons through nuclear hypercation, and and then we sent them through, diamond matrix, blah blah blah. And I mean, you're just like, oh yeah, and all that works exactly the way you think it does, huh? Oh, I mean, it's just so bad. Anyway, all right. So Melissa says, stupid spin thing wasn't true. The Earth and planets wouldn't spin. So again, just completely erroneous to the subject, in the sense that you're not going to be able to explain spin in the subnuclear world, because there isn't anything like comets hitting them and meteors, and they don't have half interactions. They have full interactions. It's over, Feynman would explain that to you. And spin would add another energy component. So then there would be photons that had extra energy from spin. Nobody's created a spinton. I mean, whatever. They don't have to be related subjects at all. Things don't have to spin. Most of the asteroids in the asteroid belt aren't spinning. It's just silly, because some things spin doesn't mean everything has to spin. It's not evidence. Sorry. Because I find a fat, stupid human doesn't mean all humans are fat and stupid. You understand? I don't know. No point. Anyway, just too stupid a comment, I have to say again. You have to do better than that. I mean, you're just making this declaration that somehow spin must be in the sub particle world because it happens in our world. I'm not spinning, by the way. Lots of things. Everything in this house isn't spinning. This isn't spinning. Whatever. Don't watch in public. Graphic language. Yes, adults. Anyway, human beings who are not shocked by the arrangement of letters. Wouldn't it be funny if there were people, I could just arrange certain numbers? Well, you can, right? 666. That scares people. You can write 666. They go, oh, all panicked. Anyway. All right, so then Michael, who's, legally blind, this isn't really your subject. You really have to see some of this stuff to, I think. Anyway, says, hi, Gary. From what I can gather about these ferrocells, they are made up of circular pieces of glass. Yes, some of them, but not all of them. There's some people have made nice square ones and made big boxes out of them, and so shape is not relevant to the function. I thought originally it was, because that's, it explains why everything bends, but it's not the right explanation for why everything bends. And not unsurprisingly, they form curved patterns. Has anyone ever tried different geometric shapes? Yes. Basically shapes without curves, yes. If the cells, I just did it with microscopic slides. If the cells are revealing the true nature of field lines, the shape of the cell shouldn't change the visual effect. Right, it doesn't appear to, and they're still kind of curvy in using square words, right? Hardware. But part of that too is how the lights are arranged. So that's the trick of it, right? Because I've seen them square ferrocell, but the lights underneath are still in a circular configuration. But that probably doesn't matter either. But anyway, okay. Thank you for the comments. Probably. Maybe. Yeah. Mostly. Yeah, that's it. Let's say mostly. All right, so I leave the drawing up, and now we'll do videos, I think, if I can find the video. That looks like a video. Yay! Hey, look at that. I got it right. And then I also have to find get this out of the way for a moment. Let's see, what folder do I need? I think download will do it. How could I have two download folders? Well, that's a real flaw in the... Maybe this one's more visible. Well, that's no good. Downloads. It's not even correct. I don't know what folder that is. Not on my computer. I think it has to be, Gary. I don't think it has to be. All right, let's move that over here so I can push the videos into there. All right, so that's okay. And me back, because I'm sort of important. Maybe. Might be. Not really important. But anyway, so let's play this little clip. So I got a few of these. They're short, and so this is one view through the microscope, and yeah, it's got there. I bought them used from some laboratory, and very dirty microscope. So I got to clean all the lenses. But anyway, so you can sort of see these lines. See, they're all kind of a little bit starting to connect. So this is fairly close to the magnet. Maybe. I don't know. Not next to it, but getting close to it. So, a half a radius away from the magnet, maybe. And you can see it really starting to form pretty, they're not straight lines, but lines. Play. It's broken. Not irritating. So these segments sort of seem to have a size, but you can see as you get a little further away, they start to break up into very regular size. So about half the size of those other things, or a quarter of that size, they start to break into these littler pieces. You can see it there. Just in, they all have a sort of consistent shape, size and thickness. And that looks like, oh, that's what ferrofluid is. It's made up of those little things. But the things it's really made up of are like 100 times smaller than that. So this stuff really is tiny little bits of iron oxide. So it is very curious. You can see they're getting kind of far apart. They obviously have some repulsion, because they're north-south. They're all facing the same. They're all magnetized in the same direction, so to speak. So they're all kind of repulsive to each other once they start establishing identity. But it's really hard to measure any kind of consistency, and I guess that's because of the ions that are used to keep the bits from sticking to each other permanently. So it's it is a really different there's a little there's a real battle going on. So the thing you really notice when they're moving is that them sticking to each other is really 50-50, whatever, 25% of the time. When they might bang into each other, they stick, and the other times they don't. It's very there's not a really strong up close bond, and it seems the stronger is a little bit further away. So you have to get past the ionic repulsion to get them to stick, which is interesting. So the ions must be really close to the surfaces, and that's what's making them more repulsive at a distance and never really very attractive. I don't know how, yes, when they get in a certain proximity, they become somewhat attractive, but it's not a very strong force until they actually stick to each other. Then they, but they fall apart really easy too. So it's just really subtle. It's not like you're just watching magnets smash into each other. There's none of that happening. It looks kind of like skin or something. See, so that patch has more fluid in it, and this darker patch, and that sort of indicates that these little bits haven't stuck to each other yet. So they're not, they haven't coalesced into visible clumps. Oh, it doesn't play. That is really weird. Let's see if I click this. No. I click the space bar, no, it just stops playing. I have to move it forward to get it to play again. Play. It didn't work either. Play. Play, please. Bizarre. Not my fault. So this isn't really perfect because I'm using a flip camera, with a micro lens I put on it, looking through the eyepiece of the magnifying glass, for the microscope. And so I have to, I'm holding it by hand. So it's a little bit difficult, the procedure. Oh, I shouldn't have paused it right because now it's not going to play. You cunt. Let's see. Oh, sorry. Damn it. I gotta learn not to say that word. Really strange that this is sticking like this. I don't really know why it's doing that. I just really don't. Go back and it plays. Well, whatever. Sorry. See, there's quite a bit of crud on the eyepiece. The next videos are better quality, so I did find a better technique. Full screen and such. better viewing. But all of these are lined up, like I said, just around the magnet, just the way you would expect. They're all pointing towards the magnet. All right, next video, please. It would be 4. Yes, that's after 3. All right, so we're getting a little better now. And it's probably all the same kind of stuff for a while here until I move the magnet, and then you can see all kinds of crap happens. So there's a little movement there where it was flowing. It flows like smoke, like just smoke. And those are little ferrous bits, but they haven't stuck to each other yet. They're not, And that's a void of some kind, apparently. And I don't know what that is, but didn't watch all of this. Kind of guy I am, But I'd be surprised. Obviously I couldn't really see it while I was doing it, but technically I knew what I was videoing anyway. I knew there wasn't anything surprising in there. Thought there was a little more happening here, but eventually we'll find something. See, but at least I'm a little better. Got a fuller screen now. Yeah, sorry, I didn't realize there was that much. That's going over the magnet. So I went over the top of the magnet to try to get to the edge. And, I'm not holding the camera right. So, technical difficulties. It's a little tricky because you have to have enough light coming through and get the camera right. I got to try to move the slide. It's hard to do all 3 things at once. The other thing that's interesting is when there's something, dirt or whatever in between, and it blocks the ferro fluid from getting to the magnet. And it all lines up like little flowy hairs. It's quite interesting. I think there's some video of that somewhere in here. There's a little bit of it. There's a little bit of it there. You see, look, and they come off. They fall off the edge. They just pile in and then fall off and move. Really subtle. But you can see how subtle their repulsion and attraction is. It's so subtle that they barely push each other away, barely attach, barely, very subtle. All right. The rest of them are shorter videos, I believe. What the hell is that stupid symbol? So now you can see them. They all look the same, almost the same size, and just connected to each other. But that's sort of an illusion. But all clearly their orientation is quite specific, and it creates a little bit of imbalances. You can sort of, I'd like to take some time to really analyze what's happening between these different places where there's an intersection of two and then something else, because that's when they bend a little tiny bit. And it'd be interesting to try to figure out exactly that mechanics. And clearly, as the density changes, the width between them changes some. So the ferrocell basically works with very powerful magnets and a much bigger field. So I'm using a very small magnet, and so I'm measuring much more subtle effects. So the powerful magnets are going to force a lot of action immediately, where this allows for some slowness in the processing of the function. All right, that was 5, so we'll go to 6. All right, so this is just showing the magnet on the slide, and when I remove it, this doesn't show up very well, but there's no fluid, no ferrous stuff underneath the magnet. That just seems bizarre in a way, but it sort of makes sense, because obviously under the magnet, it would want to turn a way it doesn't turn. It can't do that. So the repulsive side of the magnet, whatever, the south side just can't exist underneath. Say that it's north facing down, the magnet. The south pole on the little ferro bits can't exist under the magnet. They're just going to refuse. They're just going to keep pushing it out. So clearly the repulsive force in this case ends up being stronger than the attractive force. I said that the wrong way, right? The south face wants to attach to the north face. Sorry, and so it's the sames repel. So the north sides that keep trying to get away. So the repulsive force appears to be the winning force. I think that's all this video was. Yes. All right, so number 7. So here you get the flow stuff. So it's just like smoke. So when I move the magnet, everything falls apart and it just kind of reforms. And so it does all these channels of material. And part of this is because I never mixed the oil and the ferrofluid completely. So there's places where there's just oil and places where there's ferrofluid. And so that's sort of what's getting illustrated here. There's just like the ferrofluid moving through the oil field. And it's just, but it's moving in this smoke form. And the smoke will reform into those little lines. Quite interesting. But it creates a lot of motion, lots of currents, because all those little bits moving, friction and adhesion, and so it pulls the fluid, and that starts getting everything moving. Hopefully we'll get a better, oh, that's nice. So that's around the edge of the magnet. And so the flowing part is being caused because of all that motion, like I was saying. And so that's just a eddy current, so to speak. Not an eddy current magnetically, but a eddy current in the fluid. And you can just see how light these things, they barely get pushed around, and it's quite interesting. I mean, it's interesting to watch when it's, when you get a really good shot at it. And they only get a certain length, and that's it. But, they get piled up pretty thick. So that's the black corner there. They're piled up pretty thick, so you can't really get light through. They're still not sticking to each other, but they're, even though it's a thin layer of oil, it's thick enough, to create overlaps that prevent the light from getting through. Yeah, stalled again. I should have loaded them in VLC, I guess. BCL or whatever the hell it's called. Come on, any better pictures? Come on, move around, see if you can find something. This is a little tiny screen I have to look at to see any of this stuff, so where's the camera? Oh yeah, this old flip here. No, it's got a tiny little screen on it, so I can't really see whether I'm in focus or what's right. But you can see it's just very, it just went out of focus there. I'm trying to see if I can sharpen the image. But these little hairs here just wasping. But they just don't, automatically stick to each other. They have to bang into somebody a couple of times before they decide to stick. Their magnetism is so subtle. But clearly they're all oriented the same way. Heads, tails, whatever. All right, one more video. And that'll do this section of videos. There you get the stream idea really well. So the currents are moving in all kinds of directions. Obviously it's moving, perpendicular to the direction of the magnet, just because the magnet's round and I moved it. So the ones that were pointed one way are now moving a different way. And so they're creating, obviously the ones moving flat are going to create a lot more current than the ones that are already pointed in the right direction. But this smoke is basically what the ferrofluid is in its natural state. Is very smoky. And once it gets in the presence of a magnet, then it comes out of the smoke and makes the little magnets start sticking to each other, and it starts creating thicker and thicker lines. But they only get a certain thickness and only get a certain length. But you get an idea of that here. There's all kind of variation in that. I'll play that one more time just because it's kind of interesting, I believe. So yeah, hopefully I'll set up the microscope with a more stable camera and be able to take longer videos, and then then I can edit them maybe. I don't think I'm ever going to want to do all that, but we'll see. But more experiments to do. But you can really see this is 500 time magnification, 400 to 500 times. And so these are tiny slits essentially. So lots of opportunity for light diffraction here, spreading, all kinds of optical effects. And then it's a very thin layer, plus it's got glass that also creates reflections, lots of opportunity for optical effects to wildly distort what is actually physically exists. So very simple physical thing. Like I said, I did the smoke thing just because it's quite interesting. But I'm just saying the part that wouldn't really happen with a strong magnet. Everything would move to a new location very quickly, fall out very quickly, do all this. So I'm just showing you what it, how it functions. But when you have it all stable, it basically quiets down, and you just get the lines essentially, as I showed in the drawing earlier. I'll show the drawing again, because the drawing was perfectly adequate representation of what I'm saying. It really shouldn't be this one. No, I knew it wasn't that one. Shouldn't be that one, but it is. All right. So, yeah, so that's how I don't have any really hard, I'm not ready to, say I've, stripped Ken Wheeler down to his dirty underwear, but we're almost getting there in the sense that, all these claims people make about what this ferrocell is doing, they're just, they're very unscientific claims, because when you really look at what's happening, there isn't anything happening that's outside of what we know about magnets already and what they do with iron filings. It's not doing anything much different in terms of revealing the character of a magnet. And all this really has to do with is how the light's hitting from a location. So the real point would be is you're shining light, and so again it's below the magnet, and it's only going to be revealed when it hits one of the lines that are perpendicular-ish to the direction of the light. So, if I pick this location, it's going to, the photons are going to be reflected on these vectors. And that's what's curving the line, is this one has the wrong angle. So this one would have the right angle, this one would have the right angle, this one. So you could sort of see that in the fluid, that there was a little bit of imperfections, but the point is that this angle is going to be different than this angle. And to get to your eye, they have to hit bits that have the same slope, you could argue. And so instead of creating a straight line, it creates the curved line, because it has to go with the little bits that have the right angle from the location you're coming at it from. It has to be perpendicular to the beam. Like I said, I can't draw it in 3 dimensions. Unfortunately, it's a holographic image, so you sort of need 3 dimensions to illustrate, because there's 2 angles, but the 2 angles have to equal exactly the same, whatever it is, 60 degrees or something. It's some angle. So combining the 2 angles, you have to end up with the same reflection degrees to be able to get the light to come back to the observer from all these locations. So those are what's creating the lines that look like they're bending. It's just that the angles at which you can see it, because of the difference in the distance from the LED, is what's creating the effect. And those distances have to be proportional to how much you're changing the pitch. So you have to change to decide which one of these little bits reflects the light that you see. You have to the pitch this way matters, and the distance this way matters. So adding those 2 up decides which little bit, which little flat surface the light's going to reflect off of. And again, reflect maybe more than one time. There might be more than one reflection involved, in the sense that the light reflects and then it goes through the glass and is diffracted. which means its position is changed when it comes out. So that's why the thickness of the glass emphasizes the illusion, because yeah, I can draw that part. Because in typical diffraction, say this is the little bit reflecting the light, and then it's going through this glass layer that's above it. So it comes up in one location, it gets bent, and then comes up in a new location. So it's distorted by the distance. The thickness of the glass will decide how much that is, how far away from the actual place the light reflected you'll see it coming from. So you're going to see it coming from a place it isn't. Like looking at fish in water, you don't see, if you see the fish, you're not really seeing where the fish is. You're seeing a fish that's closer than where the actual fish is. Closer, right? Bends towards the normal. So you're seeing the fish farther away than the fish actually is. I'm sure it's one of those two. It just has to do with your line of sight isn't the line that like I said, just like this isn't, your line of sight says the thing is here when the thing is actually here. Yeah, just that kind of trick and such. So I probably should do some other kind of dopey drawing just to see if anybody has anything to say. And apparently, nobody's terribly interested in any of this stuff, which is, shockingly depressing, but it's the way it is. There's nothing I can do about that. So I don't know if I have anything else to go into. Got some more experiments to do. And still working on two-slit stuff and the rest of all that light diffraction. And but yes, this optical thing is really what this is about. Thin film is it's really a very complex science. I mean, lots of little bits to it. Changing this distance a little bit changes the reflective indexes. I mean, just very, very lots of stuff happening. I wasn't really able to duplicate the. I guess you need to use really the right kind of light. It's the key to these things, and so maybe a sodium light or something. But I wanted to do that two pieces of glass on top of each other thing, where the guy got that nice line pattern, and but I wasn't able to duplicate that with my inadequate. Just do something like that there. That's not a bad drawing of it. Okay, it gives dimension. This part's off. I shouldn't have put this line over here. That's inaccurate. Yeah. So because getting to the the air layer is the thing creating the pattern. It's just that's the problem. You can't even have a fair conversation on this stuff because they've turned everything into their jargon. So I mean, even to accurately explain it, I really can't say the pattern. I have to say the interference pattern, even though it's not interference. And such. Let's see how many people are in here. I guess just not worth it some days to bother. 8. It's pretty pitiful. So, not it doesn't really. It's not gaining much ground. So anybody who wishes to discuss ferrocells and their function, whether they demonstrate anything real about magnets or magnetism in general, just email ds@draftphysics.com. And if you have a microphone that works, I can get you into this room and we can discuss it. Anybody wishes to talk about physics in some other way than defending some wacky theory they have. So you either have to argue against my theory or defend conventional physics. But if you're going to argue for ether angels or something, I mean, you can. I don't mind doing that if you have some sort of evidenced theory, besides just making up fake functions that don't do anything real and have no consequence, like a hyperboloids or something, which never can be found. When you go look for them, you can't find a hyperboloid. Can't find anything toroiding. Fact. I mean, the only place they can find it is, in frozen moments inside a ferrocell. I mean, if it was hyperboloiding, why wouldn't it be moving? Why wouldn't the pattern move? If it was toroiding, why wouldn't the pattern move? It doesn't move. I guess I don't need this in the way. Yeah, that worked. So at least we got video to work, I think. The drawing isn't bad, and so I think at least we're technically functional, and we just don't have any participants. So I can't do everything. Well, I could, but I don't want to. It's too hard for me to. It's not too hard. Maybe I'll do it tomorrow. I'll just do that. I'll do a conversation with myself. I'll play both parts, the prosecutor and the defense attorney, since none of you are capable. Did notice that Google apparently did something about the cowboy, I guess. The video before last, I think it had 5 thumbs up and 65 thumbs down. That was, I said, wow, that's got to be a record ratio. I mean, I don't think I ever had a video with that bad a ratio. And the next day, it was 5 and 5. So obviously, it seems that was one person's account that created the 60 thumbs down. I mean, somebody went to the trouble to use 60 sock accounts to thumb down my video. Just amazing, crazy people on this planet. Scary people. Scary, crazy. Anyway. So they apparently fixed that. So, yay. So one small improvement. And such. Okay, yeah, it says nobody's doing anything interesting. So I don't, there's been nothing in the subscription well, so I can't get to it. It really is a little, I mean, I wanted this to stay on top in case somebody commented, right? But there's no point because nobody's commenting. Now this should, oh, okay. I have the browser moved over, so that's part of the problem. Yes, but nothing in the subscriptions at all. Just, there's just no physics people. It's all documentary science or nothing. Well, we could play Tin Man video, see what he's up to. It was somewhat interesting regarding magnets and the putting the electric current through them in an electrolysis tank. But that was another thing where it looks like something's happening, right? There's a tornado coming off the magnet and all that, but it's really not being created by the magnetism. It's being created by the fact that the ions are sticking to the magnet and moving across the magnet in an uneven path, and the uneven path is swirling the water. Nothing, no evidence of magnetic toroid, just more illusion of what they want to find, but not the real thing. Kind of like entanglement. They have an illusion that we've got an experiment that does that entanglement thing, that they're just falling for their experiments are so complicated that they're just making a mistake.
Okay, here's a little experiment. You kind of, what would you call it? Heat engine, I guess.
Oh, I was going to call it a crapper hole, but okay, heat engine. Anyway, start a painting channel. Yeah, I just don't have time to paint and unify physics and blow up the universe. It's just an awful lot of things for me to do. Our ferrocell is metaphysical. Our ferrocell is metaphysical. Not a very well-written sentence. Should have a question mark on it. They're obviously not metaphysical. It's like anything else. It's an illusion. I mean, it gives you an impression that the very nature of it is false, because your expectations of light moving in straight lines and all that stuff is being screwed with by these little mechanical pieces that are making the light go in directions your brain doesn't expect it to do. Thoughts move 7 times faster than the speed of light. Thoughts move 7 times faster than the speed of light. That's just more nonsense. You have no evidence of that anywhere. It's just absolute crap. Therefore, light is a physical object, but what the fuck is a ferrocell? An illusion? Question mark. I just showed you what it was. I just showed you the little bits inside. They're little bits, little tiny things. And I explained to you that little tiny things create diffraction in light. The light bends. That's what little things do. They bend light. The surfaces make light leave at less than usual angles. Yeah, you cracked me. What the hell does that mean? I mean, if you're not going to try to speak, some sort of intelligent language, it is physics. It's, we're not talking about some girl's shit cutter or something. You elevate it a little bit.
The chat showed on our.com. Here we have 2 middle lengths.
So it is kind of amazing, that this guy spends a lot of energy, and they're pretty well done experiments, trying to find the energy source, the magical energy source. I think metaphysics, there's no metaphysics. There's religion and there's rationality. That's all there is. There's no metaphysics. There's physics, and then there's lies and nonsense. There's no metaphysics. It is not obviously portrayed in your argument. I don't know what that even means. You're going to get blocked any minute now. This is just rubbish. It's always r squared t divided by t, whatever. Okay, one more comment. Let's see what you can do. You're not saying anything rational. You're just making proclamations. I say Sasquatch exists. That's all that sounds like to me, You're not saying anything. You're just saying, I saw a UFO. That's all. This is just baby talk. I mean, up your comment game or you're just done here.
100 mil stormwater pipe, elbow on the bottom. elbow on the top, and next to that you'll see my little fogger unit. That tube goes into the elbow. We'll hop up the ladder here so we can have a better look. The tube from our fogger unit here goes into the elbow, and it is pointing out this way. See that or not? But
no, it's not doing it.
It is.
It's not really pointing out
so
this way.
Well, it's probably pointing down. Into
Yes,
this corner,
there you
so
go.
It's not pointing down the tube.
Right.
It's not pointing directly out.
Okay, that's better. Yes, it's pointing at the elbow.
This was so we could see the effect happens here.
Half goes down, half goes up.
So the theory is the fog cools the air in the tube. That air becomes heavier because it becomes more dense and blows out the bottom. Once it gets going, it draws air in from the top. It is cooled, condensed, becomes heavier, drops down the tube. The more it drops down the tube, the cooler it gets. Comes out the bottom.
It's not an incredibly, I don't think it's enough length of pipe for all of that to be taking place, but whatever. Let's play along.
Now, the volume of air, and please don't get volume mixed up with mass, the volume of air going in the top is greater than the volume of air will be coming out the bottom. However, if we subtract moisture out of that air, the mass of air going in the top is the same as the mass of air coming out the bottom once we subtract our water particles.
So that would mean you're not going to gain anything from the experiment, obviously, if you have the same mass moving in both directions. But I mean, clearly you should have more coming out of the bottom just from gravity alone.
Only the volume has changed because the air has become more dense. So you could say compressed. Now this is a new type of wind turbine, I guess you could call it. But in fact, I believe it to be a heat engine that they are looking at. And apparently,
I could see it if you maybe put it in the ocean or something. You know, because then this whole cooling convection thing could have some hope of working. But you'd have to put a giant tank at the bottom of the ocean, and you know, the thing would probably cost you more than you're going to be able to get out of it.
Produces more energy than it takes to pump the water up to the top, spray it into the big tube, and of course the water is once again collected from the bottom. See a little dribble there from my previous runs. So that little fogger unit there uses 200 mils of water an hour, and we are raising it minus the loop at the top there 2 meters.
I don't know if he's going to tell us how exactly the fogger fogs. So is it using dry ice? Is it cooling, creating cold mist, or is it vaporizing?
So that takes about 4 joules of energy. Raise 200 mils of water 2 meters. So about 66 millijoules per minute required to lift the water up to that height. They don't use a fogger unit, they simply use misting units. So there is not a lot of water going into this tube, and the tube is very small. Their tube is something like 400 feet high.
Yes, so that's what I pointed out earlier, is this would have to be a very long tube to have any hope of functioning. So I don't know if building it on this scale really means much.
And about, well, 150 feet in diameter. And it's cone shaped, whereas mine is just straight. So we have our little switch here. and we'll switch it on and I'll show you what happens. See, at the start all the fog will come out the front of the tube, and then once it starts to cool the air in this tube here, we start getting...
I think it's going to cool the surface of the tube to create the downward convection, but whatever.
A Venturi effect, I guess you could call it, but it's not because of the fog coming out of that tube, because the air inside the tube is cooling, creating a vacuum up the top and the pressure down the bottom, so we get a flow. And we can see this flow starting to take place when the fog starts coming out top of the tube. A small amount will start to go into the tube here, cool the air, and then starts to self-feed.
I think what it's going to do is cool the tube, like I said. So I think if you just put ice around the top of the tube, you could get it to convect very quickly
through the tube. So we'll switch it on, let you have a look. You can see the fog coming out of the tube. Once the tube starts to cool, and you have the fog coming out the bottom of the tube. But like I said, the flow out of the bottom of the tube is not very great, but the flow into the top of the tube is far greater. So we'll turn this off.
Why don't you prove it by putting some smoke and see if the smoke goes into the tube? Yes. Did you do that?
And let that tube drain out and equalise the temperature. Now the temperature at the moment is 10 degrees C, so it's still pretty cold, and I think the hotter the day, the better this would work, and you would have to insulate this tube as well, would make it even more efficient, I think. So now that...
You know, unless you put it in the cold ground or put it somewhere where thermally you can take advantage of the parts you can take advantage of. Yeah.
That's all flushed out. We'll get up here, switch it on, we'll have a look again.
Tube definitely has a bias going down, so obviously more is going down than it's coming out at the end here, so it does have a cheap bias.
So as you can see, have quite a high volume of air flowing into the tube here now. There's very little volume at the bottom.
Well, obviously volume is being controlled by the amount of volume going through the tubes being pushed down also, so he's not going to demonstrate that huge volume difference. Right? Yeah, I don't think so. And you need the volume difference to be the other way around for this to mean anything, I think.
Now on their setup, they have the turbines on the bottom of the tube where the air comes out.
Yes. Okay. Makes sense to me.
And from what I'm seeing here, that would be far better having the turbines at the inlet where the greatest flow of air is.
But it's not the greatest flow because you're creating the flow artificially in this experiment. So if you did the experiment without your fogger, you might realize that the flow going in isn't as great as you think.
We'll switch that off. That's my little fog unit that's out of a domestic fan. Get plenty of them come back, little El Cheapo China things, and plenty get returned for warranty. cheaper to throw them in the bin than it is to fix them. So I just bring them home and they come in handy.
Yeah, I don't know how a regular fan does all that stuff, but oakley doke. Yeah, should show how to build a fogger out of a fan, because that would be interesting.
Okay, so let's start that up again. So now you see all the fog's flowing out of the tube. Starts to get a flow going down into the tube. And now we can see very high flow going in through the top of the tube.
Yeah, and it would be interesting is to turn the volume of the fog down if you could, or yeah, have it shoot out this way, have it actually shoot out the tube, and then cool the top of this tube and see if that creates enough convection to force the flow down, even though you're shooting it out. That would be the. But again, you'd just be demonstrating convection. You're not demonstrating anything we don't already know about, sort of.
And once again, very low flow coming out the bottom.
Low flow visibility wise, because you're converting it into water, it's condensating and cooling the surface. That's the whole point. It's making the surface cooler by condensation. And the condensation, is cooling the surface. And so the energy of the vapor is being converted into less energetic water.
I think that might be where they're making their mistake. If they wanted to make the machine more efficient, you wouldn't put the fans at the bottom of the tube, or the turbines at the bottom of the tube. You would put them up here at the top, with the volume of air going in.
You want to take advantage of the mass change. So in a sense, you still want to take advantage of whatever gravity you can. So the bottom has to have more energy, because you're converting mass and having it fall down. So it's like it's not like it's it's not hydraulic. What's the right word for that? When you get water energy. Damn, I cannot remember a damn word. My whole vocabulary is failing me. But anyway, it's not like you have a turbine you're going to turn with the amount of water that's coming out of the system. But the point is that you're creating, there's mass and it's moving down, and that means there has to be more energy coming out of the bottom of the pipe than going in the top of the pipe. As long as well, it has to be, because you're injecting energy. It just has to be.
Far greater, and the flow speed is far higher. All right, that's it from me. Interesting little experiment. I even stick a fan in here and see if it's got enough to spin it.
Yes, that would be the catch. So just take a little fan from a computer, put it on the top, measure how much voltage you get, DC fan, and then put it down at the bottom and see how much voltage you get. And that'll answer your question.
But at the moment, with what we have there, which is very little water, we're looking at 66 millijoules of energy per minute has to be recovered before it pays the price of getting the water up to the top. That is assuming a 100% efficient pump to get the water up to the top. It's not going to happen. But there is a high volume of air flowing into the top of this tube. So, yeah, maybe something to it.
I wouldn't think you would need to elevate the water. You could catch enough water from rain probably, or something else to do your particularizing of the water. So the problem, it won't be cold. So, but anyway.
Thanks for watching, guys.
No, not one of its better videos, but you'll have to do. It's what we clicked on. I do have the Feynman stuff I could play, where he's redoing the Auckland lecture substantially 10 years later, and pretty poor. He gets into an argument with a guy that's kind of funny. Just this guy is so rude, just amazing. Before the internet, there were rude people. So anyway, he was insisting that. So it's the irony of it is, to backing up my argument, the guy was insisting to Feynman that only wave mechanics can explain all these phenomenons. And Feynman kept trying to point out its probability. It isn't wave mechanics, and waves don't work because they don't work with this thing, this photo multiplier. He kept trying to get the guy to recognize. Thank you for retracting your not terribly useful crap. Anyway, so yeah, it was just kind of funny how he gets badgered to have to accept wave theory, and they did the same thing to Einstein. They just badgered him into making concessions to, well, it's like a particle, it's like a wave, and it's this particling waving, yeah, whatever. Okay, fine. It's a particle wavy thingy. And they just badgered him into doing it. And that's why I'm pretty comfortable saying this is a religion, the wave religion, because they're so fanatic. They have incredibly weak evidence to draw, and they're drawing this hard conclusion. So they're really just doing what the religious people do. They see a coincidence. Somebody prayed to God and their cancer went away. And they say, proof, God exists. And clearly that's all they're doing here. They got these tiny bits of fragments of evidence. And all of it can be understood to be circumstantial and too inspecific, not detailed enough to know for sure, too sloppy, plainly. And they're just grabbing it and saying, no, beat everybody over the head with this, bullshit that there's, every time a photon hits something, there's a new universe created. I mean, it's just, it's amazing the story they'll tell based on tiniest fragments of evidence. So anyway, I guess that's it for this evening, because nobody's participating, and participating by the rules. That is, it has to be a reasoned interaction. I have to have something reasonable to talk about, something that's not just a fantasy. What if the seven dwarfs made the universe in their potty can? I don't want to waste my time explaining why that doesn't seem like a high probability that that's how the universe got created. That there's other things that seem a lot more probable as possible causes. Just too tedious to have to debunk every made-up story people come up with. What if a talking piece of bread made the universe? I mean, they're just endless stories you can make up. Endless. They really have to be kind of endless, right? Because you can just make it into thin bread, thick bread. You can make it white or a little darker. You can make it any color. I mean, you could just go on and on and on forever and ever, putting different dresses on the bread, different kind of, shouldn't say it, anal plugs. Always have to get nasty. All right, I try to clean up my act. Try to get my camera back to normal. I tried to get myself normalized, but it just didn't work. The settings, which are just kind of funny, they don't have a restore to default. That would be helpful. because, yeah, I can't find the right settings. Anyway, I believe that's all there is. So I guess we'll just go about my business. Move on and such. It should be the right button. Not working. What does that mean? It's not moving forward. It's back there. Oh, that's right. I closed it the other way. I debarred it. All right, let's see what the 11 viewers here. Just not enough. I'll give you a second or two. Put my drawing back up. Yeah. Yeah. It's yeah, very good. Yeah, it says everything you need to see, right? I mean, it's so perfectly coherent. I get it immediately. All right, 30-second warning and such. But at least this isn't bad. It's working. The frame rate is always slow because it's a streamed thing. So I might try to do some OBS videos on this computer, but we'll see if I want to get into that nightmare. It's just so subtle, these programs. I haven't done the full update on this computer yet, but I did do the Linux update on the other computer, and it did fuck up a couple of programs. Really started fucking up my my memory space, and one of them was this program, that runs this camera program. It's some kind of, I don't know how to say it, GUVE view. So GUVOOC view. GUVCVIEW. I don't know what the hell that means. But anyway, it does work. If you're a Linux user and you use it, there's a trick. It won't record the videos unless you change the video codec to like FLV or something. It won't, at least on my computer, it wouldn't do the MP4. So just letting you know. And it doesn't have a pause feature, would be nice, but there's one that has a pause feature, but yeah, it doesn't work. So no point. But it really would be nice to be able to, make a video, pause, add some video, pause, add some video, pause. Be a nice feature. But if you use, which really shouldn't be that hard to do. I've done it a couple of times. I just don't remember to put the script somewhere where I can find it. But if you use the other thing that has a horrible name, MPEG, yeah, something like that. It can combine FLV files very fast. So, that works. So anyway, but that's enough, I think. I mean, I should do some Linux videos and some, it's just my knowledge is not 100%. You see, I just get enough knowledge to be able to fix my problems. So I hate giving people advice when I've only done it for my problem, and maybe your problem is subtly different. And so, my answer ain't going to be your answer, but some answer is better than no answer. Well, whatever. We'll see if I find the time for that. Not likely anytime soon. So anyway, till the next time. I guess there's nothing here, right? Nothing. Okay. I'll surrender. Unfortunately, no choice.